Radio. So I said before we were going to look at just some concrete examples. Well, generally speaking, what does it mean? What is a polynomial? Okay, well, it means you've got this form, right? You're going to have some coefficients, some constant terms, okay, and they have to be real numbers, right? They have to be algebraic numbers, actually. And you're multiplying that by some variable raised to an integer power, okay? And you can have a whole series of these added together, right? So I could have this plus as many as you like. Now, the problem here is my notation breaks down. So you could have way more than 26 here, but we only have 26 letters. So I'm just going to choose to end it at z, okay? And that's actually going to be a constant, right? But rather than write it just as z, I'm going to connect it to all the terms that you've got previously here, okay? Now, it's also worth remembering that each of these things in here is also its own polynomial, okay? So, I don't know, for some reason I can't get that meme out of my head, which is like, your dog, I heard you like polynomials. So I stuck a polynomial in your polynomial so you can... I can't remember how it goes after that. Anyway, more specifically, what are each of these bits and pieces called? Well, let me get a different color, and let's draw out some things here. Okay, the most important property of this polynomial is this number right here, the biggest power that you can get. Okay, this is called the degree. It's the highest power that you find in your specific polynomial. Okay, so most of the examples I just gave you were like degree 1 or degree 2. Okay. What else is important here? Well, something like this. That number and this variable stuck together. Okay, we call that a term, right? That's why it's called many terms, right? Because there's a whole bunch of them. The most important term is the one with the degree on it, right? Because that sort of defines everything else. We call that, because it's out the front, we call it the leading term. Okay. All right. What else is useful here? Well, these constant terms, they're at the front of each variable, right? We already know what they're called. That's going to be a coefficient. And naturally, the most important coefficient in the entire polynomial is the one attached to the leading term, which we call the leading coefficient. Okay, now those are the bits and pieces to do with this. One more important word apart from all of these ones that you need to get is a factor. Now, what's a factor? We've been working with factors for years now, right? How would you define a factor? If we were thinking about like whole number, like integers and that kind of thing, right? You complete the sentence. A factor is what? Okay, all right.
Completely divisible by the factor.
All right. So when we just think about numbers, right? Like say 24, okay? We would say something is a factor of 24 if, when you do this division, okay, what you get at the end is another whole number, right? Or another way you could say it is, you get a whole number and there's no other bits sort of sitting off on the end, but the remainder is 0, okay? Now, because that's to do with numbers, and we're dealing with polynomials here, okay? A polynomial factor is a polynomial that you can divide through and again, just like with our integers over here, okay, it leaves no remainder, right? Okay? To put it one more way, right? A factor is something that once you divide through, what you get at the end allows you to express a product, again, with no bits flying off on the side, okay? So I can write this as 24 is 8 by 3, okay? With no other bits hanging over here. That would be what a remainder is.